Okay, this will be example 6 for this review, and what I'm looking for is the node voltages V1, V2, V3. This is Alexander problem 318. Alright, so this is a nodal analysis problem, and let's start by step 1, which is to assign. Alright, the node voltages have already been assigned, so all I need to do is assign currents. Let's let this be I10, this one be I1 to 2, this one be I1 to 3, this one be I3 to 0, and I know for a fact that this is going to be 15. Alright, now the next thing I want to do is get to 2, which is to apply KCL. But we want to make sure that we stop and notice it's supernode time. Okay, and so what I find is that between V1 and V3 there's this voltage source which is 30 volts. Alright, now that means I need to first write a constraint equation. Alright, and that constraint equation is as simple as realizing that V3 is at the plus side of this and V1 is at the minus side, and together they have to add up to 30. Alright, so this becomes equation 1. Alright, first equation. Alright, next we want to write KCL at the supernode. Alright, so that means that we ignore that this branch between 1 and 3 exists, and we just see what comes in and what comes out. Alright, what goes out is just minus I10, minus I12, minus I30, and what comes in is just I13. Alright, because what I'm doing is I'm looking at these points here and seeing what's coming in and out of those points, alright, because that's where the supernode is connected. Alright, next up, we just need to use Ohm's law to write this in terms of the node voltages. So here we would get minus V1 minus 0 over 4, minus V1 minus V2 over 2, minus V3 minus 0 over 1, or sorry, over 8. I guess I drew this incorrectly when I drew it. Over 8. Alright, and plus V2 minus V3 over 2, which is the resistor between them, and set this equal to 0. Alright, and I would multiply here through by 8. When I multiply through by 8, I get minus 2V1 minus 4V1 plus 4V2 minus V3 plus 4V2 minus 4V3 equals to 0. Or to collect that, minus 6V1 plus 8V2 minus 5V3 equals to 0. And this is equation 2. Alright, so now we're just left with V2 as being the only node that we haven't written an equation at yet. So node 2. Alright, at node 2, coming in I have I12. I also have 15 amps. And then I have minus I23, which is going out. Alright, and if we scroll up and take a look, we can see that that is in fact the case. Okay, so that means that I'm going to have, using Ohm's law expressions, V1 minus V2 over 2 plus 15 minus V2 minus V3 over 2 equals to 0. Of course, it'd be nice for us to multiply through by 2. And when we do that, we should get V1 minus V2 plus 30 minus V2 plus V3 equals 0. So in other words, minus V1 plus 2V2 minus V3 equals to 30. All right, so now we're to step 3. By the way, this is equation 3. And on this exam, this is where I would like you to stop, is with equations here. But let's solve just for good measure to give you some more practice. All right, and when I solve, I would use matrix form because this is 3 equations, 3 unknowns. That's not very much fun. So using matrix form, I can write these equations in terms of the matrix. All right, so I've got minus 1, 0, 1, V1, V2, V3 here. So this is my X matrix is equal to B, which is equal to 30. All right, so minus 1 V1 plus 0 V2 plus 1 V3 is equal to 30. All right, similarly, I would have minus 6, 8, minus 5, and then that's 0. And then lastly, minus 1, 2, minus 1, and this is equal to 30. All right, and then in MATLAB, what I would do is take A inverse B is equal to X. And then, of course, like I said, I would use either MATLAB or a calculator. And I would get that V1, V2, V3 is equal to 30 volts, 60 volts, and 60 volts. All right, and this is my answer.